Alright, in this online lecture, we're going to be looking at how you can predict the formula for compounds that form when elements bond together. One of the things that we're going to be using a lot in this video is the ability to identify the most common oxidation state for an element, which is something that we learned earlier in the course. If you've forgotten how to do that, you might want to go back and refresh that in your memory before you finish watching this lecture. So basically, the rule that we're going to use that's going to help us to predict is that we want the total oxidation of all of the elements that combine into the compound to equal 0. Now, this rule is a pretty good rule. It's not perfect. It doesn't work every single time flawlessly, but it will almost always give you a compound that does form between the two elements that you're looking at. So for an example, we're going to get into an example here. We're going to look at oxygen and hydrogen. So oxygen's most common oxidation number is -2, and hydrogen's most common oxidation number is +1. So as it stands right now, we've got -2 and +1, and if you put those together, you get -1. And as we said before, we want our total oxidation to equal 0. And right now our total oxidation equals -1. So that's a problem. So how are we going to get the total oxidation to equal 0 if the oxidation of the two elements doesn't equal 0? The answer to that question is we might need more than one of the two elements. So what if we had another hydrogen? Its oxidation would also be +1. So now we've got -2, +1, and +1, and that equals 0. So that's the key. We want to try to get the right amount of each element so that the total oxidation will equal 0. We want the total oxidation to equal 0. So because we have one oxygen and two hydrogens, then the way that you would write this, you want to put the elements that are on the left of the periodic table first, and the elements that are on the right go second. So we'd actually put H, and then there's two of them, so we would say 2, and then there's one oxygen, so we would just say O. And that is our prediction. If hydrogen and oxygen are going to bond together, you would predict that 2 hydrogens would bond to 1 oxygen. So now that we have kind of the basic idea explained, let's look at a few more examples in kind of a little bit more rapid succession here. Let's say that instead of hydrogen and oxygen, we had carbon and oxygen. Now carbon can be plus or -4, but oxygen is -2. So since we have a -2 over here, we're going to go ahead and use a +4 over here. So +4 and -2 equals +2. That is not 0. So that's no good. No good. So we're going to have to do something over here. So we have too much positive oxidation, not enough negative, so let's throw another oxygen in. So -2. So now we have +4, -2, -2, and that's 0. And so we are good. So that means that the formula for the compound between carbon and oxygen is CO2. Now again, these are one possible formula, and for a lot of these combinations there are other possibilities. But this is a good way for a beginning learner to predict what you're going to get when two elements bond together. Okay, so let's do another example. Let's say this time let's use a metal. We haven't used a metal yet. So let's say we have calcium and we have chlorine. So calcium is +2 and chlorine is -1. And +2 and -1 is +1. So that is not going to work out for us. So what are we going to do? We need more negative oxidation, so we're going to add another chlorine. And now we've got plus 2, minus 1, and that's 0. So the formula for calcium and chlorine would be CaCl2. All right, now we've looked at a few of these. We've looked at a couple covalent ones. We've looked at an ionic one. Now let's get into something that's some of them that are a little bit more complicated. Let's say you've got aluminum and sulfur. Alrighty, so aluminum is plus 3 and sulfur is minus 2. So plus 3 minus 2 is plus 1. That is not equal 0, so that's no good. It looks like we've got too much positive oxidation, so we have to add another sulfur. So that gives us plus 3 minus 2 minus 2. Wait a second, that's negative 1. Still not 0. That's no good. And now we've got too much negative oxidation. So our only recourse here is to add another aluminum. So now we have plus 3, minus 2, minus 2. And that gives us, plus 2. This is plus 6, and this is minus 4. So we're still not there yet, and now we're back to having too much positive oxidation. The only thing that we can do is add another sulfur, because that's where our negative oxidation is coming from. So now we have plus 3, minus 2, minus 2, minus 2. And that finally gives us 0. This is plus 6, and this is minus 6. So we finally got the oxidation that we wanted there. So that means that the formula, let's see, we've got 2 aluminums, so Al2, and we've got 3 sulfurs for S3. Now, there is an easier way to do this than writing out all of this gobbledygook. Let me show you what it is. We'll go back to our aluminum and our sulfur. Aluminum, sulfur. Aluminum was plus 3 and sulfur was minus 2. If you take the number, the absolute value that is on these charges, and you switch them, and when I say switch them, I mean you send them over to the other element. So we're going to send the number with the aluminum over to the sulfur, and we're going to send the number that's with the sulfur over to the aluminum, and then use those numbers as the subscripts. So Al gets 2 and S gets 3. You get the same answer. You get Al2S3 without having to do all of this. So you can just switch these oxidation numbers. You can switch them, and when I say switch them, I mean you take the oxidation of one element and then you send that number over to the other element, use it as a subscript, and you'll get the right formula. Let's see if it works with our previous examples. We had calcium, which was plus 2, and chlorine, which was minus 1. So if we switch those, we get Ca, and you don't write 1 in a formula. You just assume that there's 1 because you wrote Ca, and then you get Cl2, which is the correct formula. See, we switched them. We switched the numbers from the oxidation. So it works for that one. Let's see, what was our example before that? It was carbon and oxygen. So carbon is plus 4 and oxygen is minus 2. If you switch them, you get C2O4. Now wait a second, that's not what we got up here. Up here we got CO2. Well, look at this. If I divide each one of those by a common denominator, and I reduce those subscripts, I get CO2, which is the correct formula. So if you can reduce these, you should. If you can reduce these, you should. And then our very first example was hydrogen and oxygen. So hydrogen is +1 and oxygen is -2. And if you switch those, you get H2O. So there you go. It's not that difficult. All you have to do is find the oxidation for the two elements that you're trying to combine. You switch the value of the oxidation and then you use them as subscripts, and then that will give you the correct formula for the compound that's going to form. As always, if you have any questions, feel free to ask in class, and thank you for watching.